We need to obtain the derivative of y with respect to x whenever we have a function given in its implicit form as cosine of x raised to the power of y equals to sine of y raised to the power of x. So let's begin. So here we will begin with our given function, the implicit function cosine of x raised to the power of y equals to sine of y raised to the power of x. What we'll do, we'll take the natural log on both sides such that we have natural log of cosine of x raised to the power of y equals to natural log of sine of y raised to the power of x. So here we can use a property of logarithm that states that whenever we have log of a raised to the power of b, so that's given by b times natural log of a. So what with this, we can use this property here, so we can bring the y and multiply it to log of cosine x. That means we have y times log of cosine of x. Similarly, for the right hand side, we have x multiplied to log of sine y. Now, what we'll do, we'll take the derivative on both sides with respect to x. So we have derivative with respect to x of y times natural log of cosine of x. So this will be equals to derivative with respect to x of x multiplied to natural log of sine y. Now we can use the product rule on both sides. So here we have derivative of y with respect to x multiplied to log of cosine x added to y multiplied to derivative with respect to x of log of cosine x. On the right hand side, we have derivative of x with respect to x multiplied to log of sine y added to x times derivative with respect to x of log of sine y. Now we'll obtain the respective derivative. So here the first one will be simply derivative of y with respect to x times log of cosine x plus y times. Now here we have log of cosine x. Here we will use the derivative of our natural log function log of x, which is given by 1 over x. Since we have log of cosine of x, our derivative will be 1 divided by cosine of x instead of x. But since we have cosine of x, that means we'll take the derivative with respect to x and derivative of cosine of x with respect to x and multiply it to our given expression y over cosine of x. This is the chain rule. This will be equals to derivative of x with respect to x, that's 1. So we are left with log of sine y added to x multiplied to. So similarly here we have log of sine y. This will be 1 over sine y multiplied to derivative with respect to x of sine y. Now let's further simplify. So we have derivative of y with respect to x multiplied to natural log of cosine x plus y over cosine of x multiplied to the derivative of the cosine function is negative sine x equals to natural log of sine y plus x divided by sine y multiplied to the derivative of sine y will be cosine of y. Now since we have a y here instead of x, so we'll again use the chain rule and multiply it to derivative with respect to x of derivative with respect to x. Right. Now let's complete it. Now we have derivative of y. So we'll transpose the second term on the right hand side to the left hand side and combine with the first term on the left hand side. So we have derivative of y with respect to x. So it will be multiplied to log of cosine x. So this one. So here we have negative x. Now we have a ratio here, cosine over sine, that is the cotangent function. So we have cotangent of y. So this will be equals to log of sine y. Now we have this y multiplied to negative sine x over cosine of x. We know the ratio sine over cosine, that is the tangent function. So that means here we have negative y tangent of x, and we're transposing it to the right hand side gives us positive y times tangent of x. Now what we'll do, we'll isolate derivative of y with respect to x, and this is going to give us derivative of y with respect to x will be equals to log of sine y added to y tan x whole thing divided by log of cosine x minus x times cotangent of y. So this is the value of derivative of y with respect to x.